In this quick review, we want to first introduce some key definitions in statistics, kind of talking about the difference between a population and a sample. So here's a question for us to start with. Suppose you wanted to determine the percentage of individuals who will vote in the next presidential election. How would you do that? All right, so let's think about that. So what statisticians want to do is they want to gauge the sentiment of an entire population. Okay, so are you going to vote in the next presidential election? But here's the question: is it feasible to call every single person of voting age in the United States and ask them if they plan to vote in the next election? No, no, you can't possibly call every single person in the United States. Okay, it's not possible for a variety of reasons. Number one, it would just take too long. You got to think about how many people there are of voting age in the United States. We're talking hundreds of millions. So it's just not feasible. So note here that what a census, and this is an official count or survey of an entire population, would be ideal. But what we're going to do here is what our goal is we're going to estimate this percentage using a sample and calculating a statistic. That's our goal. Okay, it's not possible to call everybody, so let's take this thing called a quote unquote sample and use that sample that we collect of those individuals, all right, and calculate what's called a statistic. All right, let's continue this with some putting some formal definitions to this. Okay, so we were talking about a population. So a population is the collection of all items of interest or that are under investigation. So in our case here, for our example, what our population is, it would be all the voters in the United States, all the eligible voters. Okay, that doesn't mean they're actually going to vote, but all the eligible voters. And then what we use is we use this capital N to represent how many people are in the population. So, the population in the United States is roughly 330 million. I don't know how many people there are of voting age, but let's just say it's a little bit more than half. So I don't know, let's just say it's 200 million. And again, I'm just making that up. I'm not exactly sure what the number is. All right, so obviously it's not possible to call 200 million people and ask them, hey, are you going to vote in the next election? No, no, no. Can't do that. So what we do is we take this thing called a sample, and a sample is an observed subset of the population. And so for our case here, what our sample might be the individuals from a phone survey. Like, a polling firm might call a bunch of people and say, hey, you're going to vote in the next election, da, da, da. And then lowercase n here represents the sample size. So believe it or not, in survey research, they probably only need to call between 1,000 and maybe even 1,500 people. And what's going on here is what our goal is, or what we hope is, the sample does a good job estimating or approximating the population. And you can think of data can be thought of the values, measures, or the categories recorded on these individuals. Like when you call them, are you going to vote? Yes or no? That's the category you fall into. And then a parameter is a specific characteristic of a population. So, for example, if we were to able to call all 200 million Americans and ask them if they were going to vote, that would be a parameter if we were to calculate the proportion from that, the percentage from that. And so what a statistic is a statistic is a specific characteristic of a sample. So a statistic would be like, hey, we called these 1,500 people. What percentage of those are going to vote? Well, whatever that percentage comes back to be, that would be a statistic. So parameters come from a population and statistics come from a sample. Let me give you a silly example just to see this, okay? Of the idea of a population versus a sample. So imagine you have the letters of the English alphabet, okay? And they're all represented in this circle here. Capital N here would be how many there are. There are 26, okay? And so imagine that you could calculate how many times these letters are used per word, right? So like A is used a lot because a lot of words have A in it. Z is not used a lot, all right, because there's not as many words that have Z in it as there are that have A in it. If you were to calculate the average number of times these letters show up in words in the English alphabet, that average from all these letters, all 26, that would be a parameter. But imagine you just looked at a small randomly selected subset of letters. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. That would be my lowercase n, the sample size. If you were to calculate the average times those letters are used in words, that would be a statistic because it comes from a subset of the population. Okay, I hope this first quick review kind of talking about populations versus samples and parameters versus statistics was helpful for you. As always, please reach out to your instructor for additional help.